Ahoy hoy, I'm Planet Walk, and something that I haven't really looked into all that much is flat earthers trying to prove that the earth is flat using a tool from the 16th century. Now, something that I have been assuming so far is that the quote-unquote proof that they are using is very complicated, and I'm going to have to take a while to try and understand it. But then I remembered we are talking about flat earthers here, and they have a huge amount of difficulty talking about anything more complicated than tying your shoelaces. So today we're going to take a look at a video from Mitchell from Australia titled "Globers Caught in the Sextant Trap." This should be interesting.
There is a great topic at hand at the moment, the number one flat earth proof we're calling it. It is the sextant.
You do have to love how the number one flat earth proof changes every couple of months. I remember when it was the Black Swan.
Sextants are beautiful measuring devices that, with the aid of lenses and mirrors, can enable you to measure the angle between two objects, typically between the horizon and a celestial object, such as the sun or stars.
Thank you, Mr. Sensible, for that concise and easy to understand explanation. It saves me from having to explain it myself. Now, I wonder how the flat earthers are going to misunderstand this.
The sextant is used to measure angles on a surface.
It's elevation angles, people.
Can you tell us what an angle is? Is it two straight lines meeting at a vertex? Can you confirm that?
Yes.
You see this line down here? And with triangles, this is called the adjacent. Now, this is the horizontal line. To measure an elevation angle, you must have a flat, horizontal adjacent.
Wade, has that been the argument that flat earthers have been using this whole time to try and say that the sextant proves that the earth is flat? For a number one flat earth proof, that's pretty bad. Even the Black Swan was better than that, and that had a whole lot of bendy oil platforms. But it looks like these flat earthers haven't heard of the concept of a tangent line, which means that I'm going to have to answer a question that was asked all the way back in 2018.
Now, only if that tangent line
What's a tangent line?
Center, will we be able...
So a tangent line is a line that only just touches a curve, like this line on this circle. Now, if you had someone standing on the circle where the tangent line touches the circle, that tangent line would be completely horizontal to them. And this tangent line would be able to be derived from something like a level, for example.
The two elevation values are how far above the horizontal plane the sight lines are. This horizontal is derived from the stars themselves, and it's amazingly accurate, and it matches the local horizontal precisely.
To measure an elevation angle, you must have a flat, horizontal adjacent.
So yeah, let's just ignore the fact that the globe model predicts what a sextant should measure, and there is no flat earth model that can predict anything. And also, this is an example of a reification fallacy. You're taking this line that doesn't actually exist and saying, well, that must be the shape of the earth then.
From Merriam-Webster, angle of elevation, the angle formed by the line of sight and the horizontal plane. See this guy right here? Kablooey. You need a horizontal plane.
So yes, you do need a horizontal plane. However, the horizontal plane is not actually a physical plane that you can go and touch. It is just a mathematical concept. Now, one thing that I will have to clarify for flat earthers is that just because something is a mathematical concept, that does not mean that it is no longer useful. For example, line of sight. There's no physical line extending from your eyeballs, so that is a mathematical concept. It is still useful though.
What they're saying is you need a flat adjacent, or you're not getting an elevation angle. It's as simple as that.
What we're saying is that to get an angle, you need two lines. If you don't have two lines, well, then you don't have an angle. And in the case of an elevation angle, one of those lines will be tangent to the surface of the earth. Or we could also call it level.
Elevation angle is the angle between the horizontal plane and a line of sight measured in the vertical plane. So you need a horizontal plane, both of them. You can't get around this.
Well, what about the vertical plane? Are you trying to say that not only is Earth a horizontal plane, but there's also a vertical plane, meaning that Earth is basically a 90-degree triangle? In fact, I think I have a flat Earth model somewhere. Here it is, the new flat Earth model, everyone.
Now, we form a local horizontal line perpendicular to that vertical. Now, we're going to measure this angle right here, and that's our altitude of the object.
My question here is, how are flat earthers not getting it? I mean, Bob the Science Guy literally showed a tangent line right there.
You could try to change the definition of horizontal, but you can't do it. I mean, it'll be a feeble attempt, and we'll laugh at you, and you might convince some can't fog of mirrors. But as soon as I put up a triangle, you're finished.
Well, let's ask Anthony Riley about that one, shall we?
Anthony, if a triangle has the sides 1, 1, and 1, do you know what the angles of the triangle are?
Which kind of triangle are you on about? Are you on about like a right angle triangle?
Yeah, it seems as though flat earthers have a bigger problem with triangles than we do.
You don't use triangles. You show me how you use a triangle to calculate your distance from the GP. Go. Well, let's have a look at a triangle then, shall we? So you're somewhere in the middle of the ocean. At point A, you can see a star. At point B,
no triangles involved whatsoever.
You can look that star up in the Nautical Almanac to see at this exact moment in time its GP is at point C.
No triangles involved whatsoever.
i.e. the star will be at 90 degrees to the surface at point C. Brilliant.
There's only one small problem with the graphic that Mitchell overlaid there. That only works if the Earth is flat. In reality, however, we're dealing with something more like this, where this is the angle of elevation, and this is where the star is 90 degrees above it. See, no triangles involved here.
You strange old fruit. You complete and utter gimboid. You scruffy looking nerf herder. You reject from Failures Are Us. You total smeghead. You knob socket.
So I do actually have a criticism of Mr. Sensible here. Whilst I liked most of his insults, the scruffy looking nerf herder one is something that I've heard multiple times. So it doesn't really seem original to me. So maybe come up with some original stuff, you budget conspiracy cats.
Budget here?
As soon as I put up a triangle, you're finished.
Oh, you think that you can calculate the position right below a star simply by using a triangle. How cute.
You don't like that simplicity, do you? I love this argument. I just love it.
So this really seems like a case in which Quantum Razor is trying to oversimplify something, to the extent where his argument isn't actually about the sextant. It's about angles. It's about as stupid as arguing that tangent lines prove the Earth is flat because tangent lines are flat lines.
A straight line perpendicular to it as our horizontal. That's just something the sextant does. That's the way it's designed to work. Then we do our observation, and we see the celestial object out in that direction. This is our altitude, our sextant angle, because we're measuring that angle directly off the sextant, and the angle is between the horizontal of the sextant and our star.
So that is a brilliant explanation there from Bob the Science Guy, and seeing as Mitchell from Australia included that clip in his video, it makes it very hard for me to believe that Mitchell is acting in good faith. I mean, the whole argument that they seem to be getting at here is that somehow you can't have a horizontal on a globe, even though you can, because a horizontal is not an actual physical thing, it is just a conceptual line. It's almost like they think that the horizontal somehow must follow the shape of the Earth, which honestly is not how it works. If you think that is how it works, then you're probably misunderstanding something. And the horizontal plane being a flat plane does not mean that the Earth is flat, because the horizontal plane is just a conceptual idea. As I mentioned earlier, that is a reification fallacy.
You're saying that there's a horizontal plane and that's above the plane of the Earth? So we've got
That's the horizontal plane of your eyesight, of your eye line, of the telescope of the sextant. You're making a reading with a sextant.
So just so we're clear, the horizontal plane has nothing to do with the shape of the Earth. You can have a horizontal plane on a globe Earth, you can have a horizontal plane on a flat Earth, you can have a horizontal plane on a donut Earth. The shape of the Earth does not matter.
Britannica. In the hands of a practiced observer, the modern sextant can be used to measure elevation angles with an accuracy of 10 seconds of arc. That is close enough to determine a ship's north-south position within a few hundred meters.
So my question for Quantum Razor and Mitchell from Australia is, how do you think they figure out the ship's position? Do you think they use triangles to figure the ship's position out? Or do you think they use, you know, the globe model?
It's simply over right here. There's no argument against this argument.
Well, here's the thing, Quantum Razor. I don't think your argument can even be classified as an argument. You know, arguments actually have to make sense. Your argument doesn't make any sense.
Conclusion. You must have horizontal plane baselines, like I mentioned before, the adjacent, to obtain elevation angles using a sextant. Because there are no horizontal planes on a spinning monkey ball.
Well, you can simply derive a horizontal plane from just simply figuring out level. This would be like saying that you cannot have a tangent line on a ball. That would be a stupid argument if you were to make it, and you are basically making that argument right here. So we're going to leave that there because the rest of the video is just repeating the same thing over and over and over again. Please tell me that this hasn't been the entire argument of the whole sextant thing, because if it has been, how is flat earth even still a thing? I mean, at this point, if someone were to show me definitive proof that the earth were flat, I still probably wouldn't become a flat earther, just so that I wouldn't have to associate with the stupidity that Quantum Razor is coming up with. I mean, if you're a flat earther and you've made it this far, please tell me, how are you not embarrassed about this? I should also mention that all the clips shown from Mr. Sensible, Bob the Science Guy, and I think it was Where's Wally, were in Mitchell from Australia's video. They were not something that I just put in to explain something. They were actually in Mitchell from Australia's video. But anyway, leave a like and subscribe if you liked this video. Leave a comment letting me know how hard you facepalmed from this stupidity. As always, a big shout out to my $20 or more patrons. Hugh Jarsz, M.C.Nutkin, Jane Spade, SHaKie, Wolfie, Morrie, Graymore Ghost, KidVicious, and Sacha Campbell. If you want to support me financially, you can do so on Patreon. There should be a link there. But anyway, I will see you in the next video. Between you and me, thank you for watching.